Hi, this question is about the projectile motion of a ball that is kicked with a speed 20 meter per second at an angle 37, and there can be possible these are the possible paths of the ball. It can directly hit the fence, or it can even pass through the fence, which we don't know will it go over or will it hit the fence, because this is what we have to find out in the questions. And also we have to find out how much time will it take to reach the plane of the fence. Means that if it is reaching the fence, either it is above the fence or it is hitting the fence, how much time will it take to cover 32 meters, that you also have to calculate. And then we will also draw the graphs. So let's start. So first of all, dear students, this is our x-axis and y-axis rectangular coordinate system, and this is a ball that is kicked with the speed of 20 meter per second. So in this diagram, I will show you how to make the components of the vector. Okay, because this is very important. Then we will be able to solve for the other quantities. So if I want to resolve this vector, or if I want to break down this initial instantaneous velocity vector into its components, so this is a method. I have to drop a perpendicular line on x-axis. This will give me the x component of this velocity. Okay, so this is a x component of velocity, initial velocity v0. Okay, and you should know that this initial velocity is v0 cos theta. You can find it from the trigonometric ratio. Okay, and what will be the y component? So if I repeat the same process, I have dropped a perpendicular line on y-axis. Now you can see that this is our y component of initial velocity, which is v0 sine theta. Okay, so now we have to put the values. So students, the x component that I got is approximately 16 meter per second. Now remember the significance of this 16 meter per second. This is a speed, the x component of velocity, that is responsible to take this mass to move 32 meters. Okay, and now we will put the values for the v0 sine theta, that is 20 sine 37 degrees, and that is 12 meter per second. So 12 meter per second is the speed, is the velocity that is responsible to carry the object vertically. Okay, so that's why it is the two-dimensional motion in which the object covers horizontal as well as vertical distance simultaneously. Okay, now we know one thing, that this ball is covering 32 meters. This is given in the question, and this is, let's say, a possible trajectory of the ball. Okay, right, we are not sure that is it hitting the fence or it is passing over the fence, but we know one thing, wherever the ball is either at this point or this point, or it is hitting the fence. Okay, in all of these possible trajectories, it is covering 32 meters. So that's why, if when we will apply a kinematics equation delta x, so I will use the x component of velocity. So initial velocity times t plus 1 over 2 acceleration times t square. So we know that acceleration for horizontal is 0, because we have been said that there is a no air resistance. Okay, there is a mentioned. So it means that what we have now, 32 is equals to 32 meters is equals to the initial horizontal component, horizontal velocity is 16 meter per second. So I'm writing here 16 meter per second, and this is in meters times t. So we want to find out the time, how much time it was in air. So this is the answer of that question. So that is 2 seconds. So this is the answer of the first question, and now let's proceed to the next question, which in which we have to find will the ball hit the fence or not. Okay, now I told you these are the possible positions of the ball. The ball may be at this position or wherever the ball is. If I find the vertical position of the ball. Okay, and of course we will apply the kinematics equation because this is a uniformly accelerated motion. So right now I'm going to solve the for the question B, and in which we will find out the vertical displacement. So vertical displacement, for that we will use the vertical component of velocity. Okay, so this is our one of the kinematics equation. Now you know Ay is not equal to 0, rather Ay is equals to negative g at all the points, because this is a free fall motion. So if we, what is the delta y? This is the final position, okay, minus initial position is equals to initial vertical velocity, which, do you remember how much was that? It was 12 meter per second, times t, the time that it took to reach the fence, plus 1 over 2 into negative g into t square. So I'm going to put the values y minus y0 is the initial position, and don't you think it is 0 meters because it is hit from the ground. So is equals to initial velocity is 12 times 2 plus 1 over 2 into negative 9.8 into 2 square. So students, finally we got answer, that is y is equals to 4.4 meter. So at the 2 second, at that instant of time, the ball height is 4.4 meter, which is of course more than the fence height. So it is 2.5 meters. So obviously this is the ball's position. So which means that the ball, now the most probably the ball was going like this. Okay. So it means it is obviously passing over the fence, and how high it is above the fence. So it is 4.4 meters minus 2.5, which is 1.9 meter. So it is 1.9 meter above the fence. So now let's go to the next question, which is about the graph, and we have to find the sketch the horizontal and vertical component. You remember I told you that the horizontal component will not change. Okay, and what is the reason behind that? There is a no force along x-axis, so there's a no acceleration in the direction of x, which means that the change in velocity for x is 0, which means that at all the points the x component velocity will be same. So student, it means that this is 12 meter per second. Sorry, that's 16 meter per second at all the position. But point to be noted is that as it is moving up, it is slowing down. Remember that. Why? Because as it is moving up, its vertical component of velocity is decreasing. Okay, initially it was 12, but now it will decrease. As it is going to its maximum height, it is becoming small and smaller, right? So while, when, how can we draw? So we know the velocity is 16, so that should be this line. Okay, but how long this line? It will be just for the 2 seconds. Okay, when it reached the fence. So this is a graph. Okay students, so this is a graph for the horizontal velocity. Now let's talk about the vertical velocity. You remember I told you as it is moving up, vertical velocity is getting small as it is slowing down. Okay, so why not we apply the equations of motion to find out what is the speed. So for example, at the time t is equal to 0 second, we know that the vertical component of velocity is 12 meter per second, because that was a initial vertical component of velocity you have seen in the diagram. But with the passage of time, it will decrease uniformly. Okay, and why it will decrease uniformly? Because acceleration is constant, negative value. Okay, so what equation should we apply to check that what will be the velocity at the 2 second? So plus ayt, right? This is our equation of motion. Okay, so vy is equals to 12 meter per second plus into negative 9.8, and at the 2 second the answer is negative. Okay, interesting. So that answer is negative 7.6 meter per second. So students, let's review our diagram again. So if this answer is negative, which clearly, what does it mean? It means that at the 2 second, the object is in fact falling down, not it is still going up, it's falling down. Okay. So it means that our trajectory of the ball can be like this. You see that? Okay. Because at this point, we have seen that the vertical velocity component is downward. Okay. So when we will draw at the 2 second, it is negative 7.6. So it will be a straight line. Okay. You understand? So it will be a straight line like this. But how will you know that from which point it will actually pass? Okay. At what will be its x-intercept? At what time its velocity will become zero? You understand? So students, what I'm trying to say, we know that at the 2 second, the ball is over the fence and its vertical component of velocity is negative 7.6. Okay. But this is a maximum height where the ball have x component of velocity. Okay. No doubt x component of velocity. But what about the y component of velocity? That is zero. Okay. So if I want to know at what time this line must pass from the x-axis, so for this you have to simply use this equation again. That's very simple. I hope it will not be complicated. I want to know the time, so I will put this vy0 when it will be at maximum height. This is 12 meter per second. Okay, this is 12 meter per second minus 9.8 into t. Okay, this equation will help you to understand that at what time the velocity, vertical velocity, is becoming zero. So student, this is the time 1.22 second, so which is obviously almost this one. Okay, so it means that when I will draw the graph, so I have to take this line from here. So this is a point. Okay, and this is a 12 meter per second, and so we will just join these 2 points. Okay, very simple. We will join these 2 points and we will get the graph, and how long we should extend this line when it will reach the 2 second. Okay, because we know duration of the time to reach the fence is 2 second, so that's why. And you can see here exactly at this point, at the 2 second, don't you think, if I want to check what is its velocity, so which is exactly negative 7.6, you can check from this point. Okay, this is negative 7.6 meter per second, which we had already calculated with the help of equation. Okay students, so this is the whole question about the projectile. I hope you understand this question and its solution.